Hey guys, today we're going to look at lesson 4.1. We're talking about relations and functions. So this is task 1 if you want to follow along. All right, describe relations. A relation is a set of ordered pairs, your x and y values, where x is the input value and y is the output value. The domain is the set of all possible inputs and the range is the set of all possible outputs. All right, so domain and range and relation are all definitions that you need to be aware of. All right, it says consider the relation. Select the elements of the domain for each ordered pair. All right, so if you look above, the domain is the set of all inputs. That means all x values. So from your ordered pairs, you've always got an x and a y, so your x is the first number in the ordered pair. So you're going to select 5. You're going to select 4, 3, 2, 7, and 4. 4 is already selected, so we don't have to select it again. All right, so your domain, again, all the x values in your ordered pair. All right, now it says select the elements of the range. All right, so if we look up here, x, y, the range is the y values. So the first one would be 2, and then 1, 0, and then 5, 4, and 3. So 5, 4, and 3 finishes up the y values or the range. All right, so your x values are your domain. The y values are your range. A mapping diagram shows how the elements in the domain and range correspond to one another. All right, so your domain, if you had ordered pairs, this would be your x value or your domain. And this would be your y value in your ordered pair, or these numbers are your range. All right, it says how is the element 4 in the domain different from others' domain elements? All right, so you can see 4 maps to 1 and it also maps to 3. So this would have 2 ordered pairs associated with this. So your ordered pairs would be 5, 2, 4, 1, 4, 3, 3, 0, 2, 5, and 7, 4. So that would be how you would take a mapping diagram and use that in order to find your domain and range. All right, we are going to look at task 2. So if you want to pause the video, and again, we're in lesson 4.1, but we're going to move on to task 2. Okay, so task 2 says relations and functions. And then it says identify functions. So a function is another definition that's very important. A function is a relation in which every domain value corresponds to exactly one range value. You can use a mapping diagram to determine whether a relation is a function. All right, so just a minute ago we looked at task 1 and we determined that these make up ordered pairs. And we know that each element in the domain has to be unique in order for it to be a function. All right, so a function is a relation in which every domain value corresponds to exactly one range value. Exactly one is the same thing as being unique. So this goes 1, 6, 2, 9, 3, 12, 4, 15, and 5, 15. So each element of the domain is unique or is assigned to exactly one value or one ordered pair. So this would make up a function. This mapping diagram, you have 1, 2, 2, 4, 2, 10. So because 2 goes to both 4 and 10, this one would not be a function. So it's still a relation, but it's not a function. All right, so it says compare the two mapping diagrams. Which of the following statements are true? Select all that apply. So both relations have some single elements mapping to a single element. That's true. If you look, you've got single elements going here, you got single elements going here, So that is true. Both relations have two elements of the domain mapping to the same element in the range. All right, two elements of the domain mapping to the same element in the range. So that is also correct. Both relations have one element of the domain mapping to two elements of the range. So one element of the domain mapping to two elements of the range. So that one is not true. All right, the next question says, which mapping diagram represents a function? Okay, which means all the x's are unique. Which mapping diagram does not represent a function? Choose the words to complete the answers of these questions. So only the blank first or second mapping diagram represents a function. So if we go back up here, all of these are unique. So this one is a function. This one is not unique. So the second one is not a function. So only the first mapping diagram represents a function. This is because the first has only one arrow coming from each element of the domain, while the second has two arrows coming from an element of the domain. So it corresponds to more than one range value. All right, so that's a little bit about determining whether something is a function or not. We are going to move on to task 3. So if you want to pause the video, we are going to look at task 3, continuing to build understanding about relations and functions. All right, guys, still on lesson 4.1. This is task 3, relations and functions. And now we're going to look at a table of values. All right, so it says identify functions. You can also use a table of values to determine whether a relation is a function. All right, so if you remember in the last task, we looked at a mapping diagram, but we were looking at the x values. If the x values are unique, it is a function. So if we look down through here, 0, 2, 4, 3, 1, this one is a function because these are all unique. We don't have to worry about what's in the y's, only the x's. So here, let's look at this one, 2, 0, 3, 2. Because 2 shows up twice, this one is not a function, okay? So it says, what value is associated with the x of 2 in the first table? So 2 is associated with 2. So basically, it's just matching our ordered pairs. All right, what y value? Well, y values are associated with the x value of 2 in the second table. All right, so we've got 2, 4, and 2, 5. So both 4 and 5 are associated with 2 in the second table. All right, so that represents that that one is not a function, where this one is. All right, guys, pause the video if you need to and find task 4. Task 4, again, in lesson 4.1, is still identifying functions. When a relation is graphed, you can use the vertical line test to determine if the relation is a function. According to the vertical line test, a relation is a function if and only if no vertical line passes through one or more points on the graph. The graph of two relations are shown. All right, so you can see the first graph here. All right, if I use a vertical line like my pencil and I go across, it's going to cross 2 points at once. That means this relation is not a function. If I use a vertical line or a pencil or anything like a vertical, anything that can represent a vertical line, if I go across here, it's only going to hit 1 point at a time. So that means the second graph is a function. So it says choose the word or phrase to complete the sentence. There is or is not at least one vertical line that crosses the first graph. Okay, so the first graph, it's sideways. So yes, that is a vertical line would pass at least, let's see, there is at least one vertical line that crosses the first graph more than once. Yes, it does cross more than once. All right, choose the word or phrase to complete the sentence. The blank, at least one vertical line that crosses the second graph more than one place. There is not one that crosses it because it is a function. So again, you can see this one is a function. So the vertical line does not cross in more than one place. All right, a vertical line crosses the x-axis. How does this test help you determine whether every domain value is paired with exactly one range value? All right, so the best answer for this is because it only passes one ordered pair at a time, that means that it's only going to have one in x. Each x will be unique. Where if you have something like this, like if you say, look at 2, for example, 2 goes with -2, and 2 also goes with 2. So this one has 2, where this one would not. So you can use the vertical line test to show that each element of the domain, or each x, goes with exactly one element of the range. All right, I hope this was helpful. If you have questions, please let me know.